Question number 4. Atoms are very small and most of their mass is concentrated in the nucleus. Electrons orbit at different distance from the nucleus. 4.1 is a near 1 question. A nucleus is very smaller than an atom, and this question is from the topic of the structure of an atom. Approximately how many times smaller is a nucleus than an atom? The size of the nucleus is about 10,000 times smaller than the size of an atom. So answer is 10,000 times. 4.2 is a near 1 question. The electrons in an atom can only orbit at specific distance from the nucleus. State what causes an electron's distance from the nucleus to increase or decrease. And this question is from the topic of the structure of an atom. If we have a model here, we have the nucleus, we have an electron. When an electromagnetic radiation is coming and this electron absorbs the electromagnetic radiation, it becomes excited. When it becomes excited, it moves from the low energy shell to the high energy shell and it starts revolving around the nucleus. But when this electron emits a radiation, it becomes de-excited. It will come back to low energy shell and the distance of the electron from the nucleus will decrease. Let's see the model answer. When the electron absorbs electromagnetic radiation, we can see here, it becomes excited and move to the high energy shell. It will move from the lower energy shell to the higher energy shell. Electron becomes de-excited after emitting the electromagnetic radiation and moves into the low energy shell. As a result, the distance between the electrons and the nucleus it reduces. 4.3 is an A1 question, and this question is from the topic of the structure of an atom. Atoms have different atomic numbers and mass numbers. In terms of subatomic particles, describe the difference between an atom's atomic number and its mass number. For this question, the student must remember the definitions of atomic number and mass number. Let's see the model answer. Atomic number is actually the number of protons in the nucleus of an atom only, whereas the mass number is the number of protons and the number of neutrons in the nucleus of an atom. An example is given here. The sodium has atomic number 11 and mass number 23. It means that it has 11 protons or 11 electrons. Students sometimes make a mistake. They mention the number of protons and number of electrons, which is wrong. It is number of protons or number of electrons, but the most suitable definition is the number of protons in the nucleus. If we see the mass number, it is 23 and there are 12 neutrons. So the mass of the nucleus is due to 11 protons and 12 neutrons. 4.4 is an A1 question. Now this question is from the topic of the structure of an atom and nuclear equations. Transmutation is the name given to the process where one element changes into another element. Explain and compare how two different types of radioactive decay can cause transmutation. The decay can happen as a result of emission of alpha particles or as a result of emitting the beta particles. So we are going to categorize our question into two kinds of decays, alpha decay and beta decay. Let's see the model answer. In alpha decay, the atomic number is changing by 2 and the mass number is changing by 4. We can see the example of the uranium. It has atomic number 92 and mass number of 238. It changes into thorium by emitting the alpha particles. We can see that atomic number changes by 2 and the mass number is affected by 4. So 92 changes into 90 and 238 changes into 234 by the emitting of alpha particle. We can add these together. 90 plus 2, it becomes 92, and we add these mass numbers. 234 plus 4, it becomes 238. When alpha decay happens, the atomic number decreases by 2. Whereas in the case of beta decay, we can see here the atomic number is 6 and it changes to 7 as the result of beta decay. If we add these together, 7 minus 1, it becomes 6, and 14 plus 0, it remains 14. The reason is one of the neutron has changed into proton, but the mass number remains same because the definition of the mass number is number of protons plus number of neutrons. If there are 6 protons and 8 neutrons, one of the neutrons changes into proton. So we have 7 protons and 7 neutrons, but the mass number remains same. 7 plus 7 is 14. So beta decay happens when a neutron changes into a proton. So the number of protons increases by 1. In both cases, the atomic number changes. We can see here the atomic number changes here, whether the alpha decay happens or beta decay happens. In beta decay, the atomic number increases by 1, and alpha decay, the atomic number decreases by 2. We can see here atomic number 92, it decreases by 2 and become 90. Whereas as a result of beta decay, the atomic number increases by 1, it changes from 6 to 7. Therefore, a new element is formed as a result of transmutation, means as a result of alpha decay or beta decay, we have a new element.